Welcome to the Materials Lab. I'm going to give you a little overview of the materials group, our role within PACCAR, and show you some of the equipment we have in our laboratory for the testing that we do here at the PACCAR Tech Center. So the materials group is made up of experts in all the major materials that we have on the vehicle. From our metal materials, our plastics, elastomers, composite materials, our coatings. We even have people dedicated to looking at the coating systems and engine materials and fluids that we use in the vehicle. We have several different roles. We look at new materials and manufacturing processes used throughout our industry. We also work a lot with our division engineers down at Peterbilt and Kenworth to develop material-specific validation requirements for new parts and components that they're working on. We perform some of that validation testing here in-house at the PACCAR Tech Center. We also work a lot with our suppliers and third-party laboratories for testing that they may be responsible for performing. We'll also evaluate parts that may have had issues during validation testing out in the structures lab or on the durability track, or even after production launch out in the field. To do that work, we have several different types of equipment here in the materials laboratory. I'm going to give you some examples of some of the different types of tests that we do. We do a lot of work in validating the coatings that we use on the vehicle to make sure that they're going to last the life of the truck. We have several salt spray chambers and environmental conditioning units that we test materials in to make sure those coatings are going to last. We do things like paint adhesion testing to make sure the paint isn't going to peel off before and after those environmental conditioning cycles. We also do similar environmental conditioning tests on all of the other materials that we use on the vehicle, such as our adhesives and plastic materials, where we'll do long-term heat aging or harsh environmental conditioning cycles. And we'll test those materials before and after to understand the effect on the material's strength and stiffness. We'll do tensile testing on all of our plastics and metals and elastomers to understand the relationship of load versus displacement. Especially on our adhesive joints, we'll test those samples after our harsh environmental conditioning at high and low temperatures to make sure that those materials are going to behave as we need them to at the temperature extremes they'll be operating under. For our composite parts, we'll do things like burnout tests, where we put the composite material in an ashing furnace and burn off all of the resin. Or we can look at the fiberglass material that's left behind, as well as the filler, make sure that the fiberglass is flowing as it should be in the tool and that we have the right quantity of fiberglass to resin and filler in the part. Another test that we perform on our materials is impact resistance. We'll take test plaques of the materials that we're using in production or actual cut samples from parts and run high-speed puncture impact testing to understand how ductile or brittle the material is going to be at those operating temperature extremes. Another tool that we have for evaluating materials at their operating temperature ranges is our dynamic mechanical thermal analyzer, or DMTA for short. Here we take a small sample and put it in our DMA, and we can test the stiffness of the material over the whole operating temperature range. So very quickly we can characterize how that material is going to behave in the environment that it's going to be operating in. Looking at how these parts are going to work, whether they're operating in the hot summer heat down in Florida pumping concrete or somebody working on the ice roads in the Alaska winter. Now I'd like to talk to you about some of the analytical testing capabilities that we have here at the Tech Center. This gives us the ability to look at things at very high magnification, understand really what the microstructure is of what we're looking at, or very small features that we might be interested in, or what elements or molecular structure might be present in the materials that we're looking at. We have several different types of microscopes in this laboratory. One of the types of microscopes may be the kind that you're used to seeing, where you're looking through two binoculars through an optical lens to see something at higher magnification. We have a couple different types of those microscopes, but they use a fiber optic cable so that we can get information digitally on the screen that we can then take measurements of at high magnification to very quickly get that digital information to send to the engineers that we might be working with to solve an issue. We also have an inverted microscope that gives us the ability to very accurately measure coating thickness on all of the different coating systems that we have on the vehicle to make sure that they're meeting our specifications to give us the long-term corrosion resistance and protection that we're looking for. In some of the other areas in the laboratory, we have a thermogravimetric analyzer that gives us the ability to look at what temperature different materials degrade at and what those decomposition components are that come off at different temperatures. We also have an infrared spectrometer that gives us the ability to get a molecular fingerprint on the materials that we use on the vehicle. So we can see if those materials have degraded over time from testing or due to use in service, or if a supplier has changed the material from what we had originally specified. In the back corner of the laboratory, we have our non-contact profilometer. That gives us the ability to look at surface roughness of materials to see how they have worn or what they might look like in the original state. We do a lot of work looking at engine components on that piece of equipment to understand what type of wear is occurring and making sure we're selecting the best materials and lubricants to minimize the wear on our engine components. We also have a smart microscope that has the ability to do some automated image analysis. So it can do automated micro hardness testing to look at the hardness through a weld area or from a heat treated part. It can also do some automated particle size analysis so we can understand what type of particles our filter systems are capturing. We also have our scanning electron microscope that has several advantages over the optical microscopes. Instead of using optical light, it uses an electron beam that's generated at the top of the column. It's then focused as it goes down the column onto the specimen in a vacuum chamber. Those electrons hit that specimen and bounce off into several detectors that create a digital image that we get on the screen. Here we can see things at up to 100,000 times what you can see with the naked eye versus about 10,000 times what you can see with optical microscopes. Another great advantage is as those electrons hit that material, they actually generate, the material will actually generate X-rays that we can collect in our EDAX system and measure the energy level of. And those energies correspond to the elements that are present in what we're looking at. So this gives us the ability to very accurately understand what elements are present in the materials that we're looking at. If we're looking for any defects or anything that shouldn't be in a particular material, or just trying to characterize what that material is made of. These are some of the tools that we have here in the PACCAR Materials Laboratory to support PACCAR in making engines and vehicles that are going to last long and meet our customer needs for the driving environments and conditions that they're operating in.